In the vast, dark expanse of space, something is sending us a signal. It's steady, it's rhythmic, and it's unlike anything we've ever encountered. Scientists have been trying to crack this cosmic code for decades, but it remains a mystery. What is this signal? Where is it coming from? And why can't we understand it? Join us as we dive into the enigma that has baffled the brightest minds in the world. This is the signal that scientists still can't explain. In the quiet, humming environment of an observatory, nestled away from city lights, a telescope was busy scanning the cosmos. It was late at night. The air was cool and still. The sky was clear, a vast canvas of stars. It was during one of these quiet nights that a peculiar signal was first picked up. The telescope, a marvel of modern technology, was designed to detect subtle changes in the cosmos. It was tuned to listen for faint whispers from the universe, whispers that could tell us about its origins and mysteries. The conditions were ideal. The telescope was pointed towards a seemingly empty patch of sky. It was a patch that had been observed countless times before. Nothing unusual had ever been detected there. Yet, on this particular night, something different happened. The telescope picked up a signal. It was weak, almost imperceptible. But it was there. It stood out against the background noise of the universe. The signal was unlike anything that had been detected before. It didn't match any known pattern or source. The exact time of detection was noted meticulously. It was crucial for further analysis. The signal was recorded, its characteristics carefully noted. The conditions under which it was detected were also documented. Every detail mattered. The telescope's position, the weather, the time of night, all these factors were considered. They were pieces of a puzzle that scientists were yet to solve. The signal was a mystery. It was a challenge. And it was an opportunity to learn more about the universe and its secrets. Fast radio bursts, FRBs, have baffled scientists for over a decade. These intense pulses of radio waves last for just a few milliseconds. Their frequency can range from 300 MHz to 8 GHz. This wide range is unusual. Most known radio sources in the universe have more specific frequencies. The duration of FRBs is another puzzle. They are incredibly short-lived. Yet, they release a tremendous amount of energy in that brief time. For comparison, some FRBs can emit as much energy in a millisecond as the sun does in an entire day. This makes their origin even more mysterious. Patterns of FRBs add to the intrigue. Some FRBs repeat, while others do not. The ones that repeat follow no discernible pattern. This is unlike most known astronomical phenomena. Pulsars, for example, emit radio waves at regular intervals. FRBs, however, seem to follow their own rules. Their randomness makes them hard to study and understand. One of the most unusual characteristics of FRBs is their dispersion. This is the delay between higher and lower frequencies arriving at the telescope. The dispersion of FRBs is much greater than expected from sources within our galaxy. This suggests that FRBs originate from very distant galaxies. Yet, their exact location remains unknown. This makes it challenging to pinpoint their source. The unexpected signal, a series of regular pulses, was detected by a telescope in a quiet, starless night. It was such a peculiar pattern that it caught the attention of astronomers. At first, scientists were puzzled. They had never seen anything like it before. The regularity of the pulses was striking, like a clock ticking in the vastness of space. Some researchers initially thought it might be a glitch in the equipment or interference from Earth. Skepticism grew among the scientific community. The signal's origin and nature were unclear. Some scientists argued that it could be a natural phenomenon, perhaps a pulsar or a quasar, but the regularity didn't fit. Others speculated about human-made interference, maybe a secret military experiment or a malfunctioning satellite. The signal's consistency and strength made it hard to dismiss. It was a mystery, a challenge to their understanding of the universe. Despite the confusion, urgency spread among researchers. The signal was too intriguing to ignore. Teams were formed to analyze the data, to search for patterns, to rule out any possible explanations. Meetings were held, papers were written, and debates were fierce. Some scientists were eager to share their findings with the public, while others cautioned against jumping to conclusions. The scientific community was divided, but united in their quest for answers. The signal had sparked a wave of curiosity, a driving force in the scientific world. Scientists have long been fascinated by unexplained signals, often embarking on numerous attempts to replicate and understand them. One such signal, known for its mysterious nature, has sparked several efforts to detect it again, each with its own set of challenges and outcomes. These attempts have involved various methods and technologies, all aimed at capturing even the faintest hint of the enigmatic signal. One significant attempt involved using advanced radio telescopes to scan the same frequencies where the signal was initially detected. Researchers hoped that by employing more sensitive equipment, they could pick up the signal again. However, these efforts often faced issues with background noise and interference from other celestial bodies. The sheer vastness of space and the potential variability of the signal made it incredibly difficult to pinpoint its origin or detect it consistently. Another approach included using multiple telescopes simultaneously to cover a broader area of the sky. This method, known as interferometry, combines signals from different telescopes to create a more detailed image. Despite its promise, this technique also encountered hurdles. The signal's transient nature meant that it might appear and disappear too quickly for the telescopes to synchronize and capture it. Additionally, the complex coordination required between telescopes often led to logistical challenges, further complicating the detection process. Some scientists turned to innovative technologies, such as machine learning algorithms, to sift through vast amounts of data in search of the signal. These algorithms were designed to identify patterns and anomalies that might indicate the presence of the signal. However, the sheer volume of data and the subtle nature of the signal made it difficult for even the most advanced algorithms to distinguish it from background noise. Moreover, the lack of a clear pattern or repetition in the signal's appearance made it challenging to train the algorithms effectively. Despite these efforts, the signal remained elusive, leaving scientists to continue their quest for answers. Scientists have explored various cosmic phenomena to explain the mysterious signal, often referred to as the WOW signal, but many have been considered and later rejected. Initially, researchers looked to pulsars, rapidly spinning neutron stars that emit beams of electromagnetic radiation. These beams can be incredibly regular, like a cosmic lighthouse. However, pulsars emit signals across a broad range of frequencies, whereas the WOW signal was concentrated in a very narrow band. This discrepancy made pulsars an unlikely candidate. Another cosmic phenomenon considered was quasars, extremely bright and distant objects powered by supermassive black holes. Quasars can emit intense radiation, but their signals are broad and spread across many frequencies, similar to pulsars. Additionally, the WOW signal's duration and intensity didn't match the expected behavior of quasars. The signal was too brief and too focused to be attributed to these massive, distant objects. Meteors and other celestial debris were also on the list of potential explanations. When meteors enter a planet's atmosphere, they can create brief radio frequency bursts. Yet, these bursts are typically irregular and vary in frequency. The WOW signal, in contrast, was a steady, narrowband signal that lasted for 72 seconds. The consistency and duration of the signal didn't align with the characteristics of meteor-generated radio bursts. Stars undergoing dramatic changes, such as flaring or eruptive events, were also examined. These events can produce intense bursts of energy. However, the WOW signal's narrow frequency range and the lack of any visible counterpart in the sky made this explanation unlikely. Stars undergoing such events typically emit energy across a wide spectrum, and their locations can often be pinpointed. The signal's elusive nature and specific frequency range left researchers with more questions than answers. Despite these thorough investigations, none of the considered cosmic phenomena could fully account for the signal's unique characteristics. Some scientists have explored the possibility that the signal, known as the WOW signal, might have an artificial origin. This hypothesis is based on several intriguing observations and considerations. The signal was incredibly strong and brief, lasting only 72 seconds, which is unusual for natural cosmic phenomena. Its frequency was also very specific, falling within the hydrogen line, a range often associated with potential extraterrestrial communications. This precision hints at intentionality, as natural processes typically produce broader, less defined signals. The signal's origin is another clue that has sparked speculation. It came from the direction of the Sagittarius constellation, near the star Tau Sagittarii. This region is not known for any significant natural radio sources. Additionally, the signal structure was highly organized, with a clear peak and rapid decay, which is more characteristic of artificial transmissions than natural ones. Scientists who support the artificial signal hypothesis argue that these features align more closely with what one might expect from an intelligent source. One of the most compelling arguments for the artificial signal hypothesis is the signal's statistical improbability. The odds of a natural cosmic event producing such a precise and brief signal are extremely low. This has led some researchers to consider that the signal might be a deliberate attempt at communication. The fact that the signal has not been detected again, despite extensive searches, adds to the mystery. Some speculate that it could have been a one-time transmission, perhaps a test or a beacon meant to attract attention. The lack of repetition, while frustrating, also means that the signal cannot be easily dismissed as a natural phenomenon. The WOW signal, detected in 1977, remains one of the most intriguing mysteries in the search for extraterrestrial intelligence. Astronomers picked up a strong, narrowband radio signal that lasted for 72 seconds. It was so named because of the note, "Wow," written by the astronomer who discovered it. The signal appeared to come from the direction of the constellation Sagittarius. However, despite extensive follow-up observations, the signal was never detected again. This absence of repetition has left scientists baffled and eager for more data. The lack of follow-up signals has made it challenging to determine the source or nature of the WOW signal. Many theories have been proposed, ranging from natural phenomena to extraterrestrial origins. Some scientists suggest it could have been caused by a distant star or a unique cosmic event. Others speculate it might have been a man-made interference. The fact that the signal has not been detected again makes it difficult to test these hypotheses. The silence after the initial discovery has left many questions unanswered, fueling ongoing debate and curiosity. The unanswered questions surrounding the WOW signal highlight the challenges in the search for extraterrestrial intelligence. Scientists have continued to monitor the same region of the sky, hoping for a recurrence. Advanced technology and new methods have been employed, but so far, no similar signals have been found. This lack of follow-up has led some to question whether the signal was a one-time event or if it was even detected at all. Despite the uncertainty, the WOW signal remains a fascinating topic of study, driving scientists to develop better tools and strategies for detecting potential extraterrestrial communications. The mystery endures, a testament to the vast unknowns that still lie beyond our understanding. In the vast expanse of the cosmos, a mysterious signal known as the WOW signal was detected in the 1970s. It remains one of the most intriguing and unexplained phenomena in the field of astronomy. The signal's significance lies not just in its enigmatic nature, but in how it challenges our current understanding of the universe. It pushes the boundaries of what we think we know, prompting scientists to question and re-evaluate established theories. The WOW signal was unusually strong and narrow-banded, characteristics that are consistent with an artificial origin. This is what makes it so fascinating. It came from the direction of the Sagittarius constellation, near the star Tau Sagittarii. The signal's intensity and frequency have led some to speculate that it could be a sign of extraterrestrial intelligence. However, despite extensive searches, no repeat signal has been detected. This lack of repetition is perplexing and has left scientists scratching their heads. What makes the WOW signal particularly challenging to our understanding is its fleeting nature. In the vast timeline of the universe, a signal that lasts only a short time is a rare anomaly. It's like finding a single footnote in an endless book. This challenges the idea that any potential extraterrestrial civilizations would be constantly broadcasting signals. It suggests that perhaps signals are more transient, or that they are not being broadcast in all directions. This forces scientists to reconsider how they search for extraterrestrial intelligence. Moreover, the signal's origin near Tau Sagittarii is also thought-provoking. This star is not particularly notable, making the signal's origin even more mysterious. It's like finding a hidden treasure in an ordinary field. This challenges the notion that only the most obvious or prominent stars would host intelligent life. It implies that life, if it exists elsewhere, could be found in the most unexpected places. This has broadened the scope of where scientists look for signs of extraterrestrial intelligence. It has also fueled debates about the prevalence of life in the universe. As we wrap up our journey into the mysteries of the WOW signal, we are left with more questions than answers. This fleeting burst of radio waves, detected nearly 50 years ago, continues to baffle scientists and enthusiasts alike. While we've explored possible explanations, from distant stars to advanced civilizations, the truth remains elusive. What we do know is that the WOW signal has sparked our curiosity and pushed the boundaries of our understanding. It reminds us that there's still so much we don't know about our universe. So, what do you think? Could the WOW signal be a message from an alien civilization, or is there a more mundane explanation? Let us know in the comments below. And if you're as fascinated by the mysteries of the cosmos as we are, stay tuned for our next exploration into the unknown. Together, let's keep looking up and wondering.